Nuclear energy 3, nuclear fusion. So nuclear fusion is, if you like, it's the opposite of nuclear fission. Two small nuclei fuse together, and looking at the graph here, we'll see that this is energetically viable. The resulting nucleus has a larger binding energy per nucleon, so energy is released. A good example is the deuterium and tritium coming together, making a helium and a neutron. Okay, now I've given you here the masses of all the particles. Perhaps you might like to have a go now, work out the difference in mass between the left and right hand side and how much energy that will release. I've given you a little shortcut to do that, and I'll show you the answer in 3, 2, 1, and there's the answer. Okay, to get fusion to happen, we have to get these nuclei close to each other, the deuterium and the tritium nuclei, very, very close. They don't want to be close because they're both positively charged. So if we can get them close to each other, then the strong nuclear force will take over and they will fuse together. You can think of it as two magnets which are repelling each other, but the magnets have got Velcro on them. If they get close enough, then the Velcro will stick them together. But to get them close enough, we need to get them moving very, very quickly. So we need very, very high temperatures. This is a type of reactor called a Tokamak, and it's basically a particle accelerator. We speed up the particles, we get them very, 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 very hot, up to about 100 million Kelvin. And bear in mind that the temperature of the core of the sun is 15 million Kelvin. We're talking very, very hot. And in this plasma, which is contained in a magnetic bottle, this is where the fusion reaction will happen. What's good about nuclear fusion? Virtually no nuclear waste. There is some waste, but it's not as nasty as your fission waste. It's virtually renewable. If you can find a source of nuclear fuel, these isotopes of hydrogen, it's virtually renewable. And nearly all of our energy comes from nuclear fusion anyway, as in from the sun. The problems with nuclear fusion is that we have got small-scale fusion working, but a commercially viable full-scale fusion reactor, not yet, no. It's still in the experimental stage, and a supply of fuel is not guaranteed. For example, if you're using the deuterium-tritium reaction, where are we going to get tritium from?